Hi guys, you're welcome to Halogenous Ideas. In this video, we're going to be talking about computer software processing models. We're going to be talking about processing models and networks. So, processing models, they define how computer systems handle tasks and execute operations. Different type of processing models cater to specific needs and requirements. Let's dive into each type in detail. So the first one we're going to be talking about is batch processing. Batch processing involves the execution of a series of jobs or tasks without user interaction. The jobs are collected and processed sequentially, and the results are generated without immediate feedback. Okay, so the characteristics of batch processing: no user interaction during the processing of the jobs, and jobs are executed at a specific time or in a sequence. So suitable for tasks that can be automated and performed in bulk. For example, the payroll processing, where employees' salaries are calculated in batches at the end of each month. So we also have the real-time processing. Real-time processing involves the immediate processing of data as it is generated or received with minimal delay. It is crucial for applications that require instant responses. Okay, so the characteristics is that data is processed as it arrives without delay, and it is common in applications like stock trading, video streaming, and monitoring systems. Real-time processing also it is used in air traffic control systems where the position of aircraft is continuously monitored and analyzed in real time for immediate decision making. It is also used in the medical field as well, where time is very very important. We have online processing, also known as interactive processing. This involves user interaction with a computer system in real time. Users input requests and the system responds promptly. Okay, so the characteristics: user interacts with the system in real time and the system provides immediate responses to user inputs. Common in applications like online banking and reservation systems and e-commerce as well. Online shopping websites, where example, online shopping websites where users can browse products, add items to cart, and make purchases in real time. We also have time sharing processing, which allows multiple users to share a computer's resources simultaneously. Each user is allocated a time slice and the system rapidly switches between users. So, characteristics: multiple users access the system concurrently. Also, the CPU time is divided into small time slices, allocating each slice to a different user. So it supports interactive tasks efficiently, and examples include Unix and Linux operating systems. So they utilize time sharing for multiple users to work on the same system simultaneously. So we also talk about distributed data processing, which involves the use of multiple interconnected computers to process data. Tasks are distributed across the network, and each computer contributes to the overall processing. Okay, the characteristics includes: processing tasks are distributed across multiple machines, easily scalable by adding or removing processing nodes, enhance reliability and fault tolerance. Then the example will include cloud computing platforms where tasks are distributed across a network of servers for improved scalability and resource utilization. Okay, these processing models play a crucial role in shaping how computers handle various tasks. Organizations often choose a processing model based on their specific needs, the balancing factors such as the efficiency, responsiveness, and also resource utilization. Okay, so we move on to networks now. A network is a collection of interconnected computers or devices that can communicate and share resources. Okay, networks enable the sharing of information, files, and services, facilitating collaboration and communication amongst users. There are different type of networks, each with its own characteristics and use cases. Okay, the type of networks that we have the hierarchical networks and we also have the peer-to-peer networks. The hierarchical networks, devices are organized in a tree-like structure with multiple levels of hierarchy. Each level of hierarchy is responsible for specific functions. The characteristics is that we have a centralized control for it. Typically, there is a central node or server that controls and manages the network. So it is also easily scalable by adding or removing nodes at different levels. Okay, devices are assigned specific roles based on their position in the hierarchy. So, an example, we have the enterprise networks. Large organizations often use hierarchical networks where central servers manage departmental servers, which in turn manages individual computers. All right. In organizations where you have the administrative department, the personnel department, the HR department, and all those, so you can see that we have different access levels to the whole system. So that is the tree like structure. We have the administrative level down to the departmental level, then down to the each individual employee or user of the system. We also have the peer-to-peer network. In a peer-to-peer network, all devices have equal status, and each device can act both as a client and a server. There is no centralized control or hierarchy. Okay, so the peer-to-peer networks are decentralized, meaning that there is no central server. Each device can communicate directly with others. So all devices have equal authority and can share resources. They have equal status. And it has a simple network, and it is generally simpler to set up and suitable for small to medium sized businesses. So example, we have file sharing networks like the P2P networks are commonly used for file sharing applications like the BitTorrent, yes, where users can share files directly with each other without a centralized server. Both hierarchical and peer-to-peer networks, they have their advantages. An example of this is your Zender, the Zender. So you can connect two mobile phones together or even to a computer, you share files and all those. So both hierarchical and peer-to-peer networks have their advantages and are suited to different scenarios. The choice between them often depends on the size and the purpose of the network, as well as considerations such as scalability, centralized control, and ease of management. Large organizations may prefer hierarchical structures for better control, while smaller groups may opt for the simplicity and the flexibility of peer to peer networks. Alright, so take this out. So we can classify networks as we can classify networks the based on based on it being an hierarchical network or the peer-to-peer network. So based on the access level basically, or you can classify networks based on their scope, their size, and the geographical coverage. Okay. So the first one we're going to be talking about is the local area network. The local area network. It has limited geographical area, which is just within a single building or a campus. It has high data transfer rates, typically owned, set up, and maintained by a single organization, and it is commonly used for connecting computers, printers, and other devices within an office or a building. We also have the wide area network, which covers a larger geographical area, often spanning multiple cities or even countries. So it has lower data transfer rates compared to LANs, and it connects LANs over long distances, often using public or private communication lines. Enables the sharing of resources and information across wide regions. So we also have the metropolitan area network. So it is the intermediate scope between the local area network and the wide area network, typically covering a city or a large campus, and it offers higher data transfer rates than the wide area networks, but not as fast as the LANs. Connect multiple LANs within a specific metropolitan area. We have personal area network, which is very small, typically within the range of an individual person's maybe office or something like that, or the space around their devices. So it connects personal devices like smartwatches, tablets, laptops, phones, and all. So it's often established using technologies like Bluetooth or infrared. Yes. So we also have the home area network, which is a network within the confines of a home. So it connects devices within a household, such as computers, smart TVs, and smart home devices. So it facilitates communication and sharing of resources among home devices. We also have the global area network, which you might want to refer to as the internet. So it spans the entire globe, and it utilizes satellite or submarine communication links, provides global connectivity and supports worldwide communication. We have virtual private networks, which can be implemented within any physical network, which is the LAN or the WAN, but it's not tied to a specific physical location. Okay, so it utilizes encrypt connections over the internet. It offers secure It offers secure and private communication, often used for remote access to a corporate network. We also have the intranet, which is limited to an organization. It's a private network used using internet technologies within an organization. It facilitates internal communication, collaboration, and resource sharing within the organization. We have extranet. So, for one reason or the other, an organization might want to expose part of its system to its stakeholders or its partners, or its investors. So, you might use the extranet to make resources of the organization available to third party agents. So it extends beyond the organization to include selected external partners or customers, enables authorized external entities to access certain parts of the organization's network. It enhances collaboration between an organization and its external stakeholders. We also have the cloud network, which utilizes cloud computing services. Resources and services are hosted and accessed over the internet, and it offers scalability, flexibility, and cost effectiveness. All right. So these network types serve different purposes and are designed to meet specific requirements based on their scope and usage scenarios. The choice of network types depends on the factors such as the geographical coverage, data transfer rates, security, and the nature of the communication required. All right. So let's discuss briefly the history of the internet. So, this history is a fascinating journey that spans several decades and involves the contribution of numerous individuals and organizations. Here is a brief overview of key milestones in the history of the internet. So, the concept of a global communication network was initially explored by researchers in the 1960s. The idea was to create a decentralized system that could withstand a nuclear attack, basically. Then the ARPANET came up in 1969. The first practical implementation of the internet came with the creation of ARPANET by the United States Department of Defense. On October 29, 1969, the first message was sent over ARPANET between computers at UCLA and the Stanford Research Institute. So we have the TCP and the Internet Protocol, the Transmission Control Protocol, and the IP during the 1970s played a crucial role in standardizing communication protocols across the network. This laid the foundation for the new day internet. We have the email and the domain name systems. So Ray Tomlinson sent the first email in 1971, revolutionizing communication on the network. In 1983, the DNS was introduced, simplifying the way web addresses were specified. Then the World Wide Web came up in the 1990s. So in 1889 stroke the 1990s, Tim Berners-Lee, working at CERN, proposed the World Wide Web in 1989 and implemented the first successful communication between an HTTP client and server in 1969. The release of the Moasic web browser in 1993 marked the beginning of the graphical web. All right. Then we have commercialization and the dot-com boom. The internet saw rapid commercialization in the mid 1990s, leading to the dot-com boom. Companies like Amazon, eBay, and Yahoo emerged during this era. Broadband and high-speed internets. The 2000s witnessed a significant expansion of broadband and high-speed internet access, making it more widely available to households. This contributed to the growth of online services and content. Social media and Web 2.0. I think we are currently in the era of Web 3. Platforms like Facebook, Twitter, and YouTube came up, defining the era of social media and user generated content. The concept of Web 2.0 highlighted a shift towards interactive and collaborative online experiences. Then we have mobile internet and smartphones. The widespread adoption of smartphone and mobile devices brought about a new era in internet usage. Mobile internet access became a standard feature, transforming the way people connect and access information. We also have cloud computing and IoT. Cloud computing services such as the AWS and the Microsoft Azure gained prominence. IoT further expanded connectivity by integrating everyday objects into the internet. So, and the internet is an ongoing development. So, ongoing development includes the rise of 5G networks, continued expansion of IoT, advancement in AI, and an increased focus on cybersecurity and privacy. The internet has evolved from a small scale research project in the 1960s to a global phenomenon that influences nearly every aspect of modern life. Its impact on communication, commerce, education, and entertainment is profound, shaping the way people connect and share information worldwide. Okay, so let's discuss some other terminologies associated with computer networks. We have the server, and the server is a computer or system that provides resources, services, or data to other computers or devices on a network. It acts as a central point for storing and managing information, applications, or resources that can be accessed by multiple users. Examples include web servers, file servers, mail servers, database servers, and application servers. Okay, so talking of file servers, a specialized server that stores and manages files, allowing users to access and share them across the network. It centralizes file storage and management, making it easier to collaborate, backup data, and control access to files. We also have value added process, a process that enhances or adds value to data or information as it passes through a network, such as error correction, data compression, or even encryption as well. So it improves the quality, reliability, or security of the data transmission. It also adds to the integrity of the data as well. So we have the host, a computer or device that is connected to a network and is capable of sending and receiving data. It can be a personal computer server, a smartphone, tablet, or any other device with a network interface. Okay, so we have a host also. It might be serving as the host computer, the one opening the network, the one creating the network, the one managing the network as well. So then we have the node. Any device on a network is what you call a node. It includes computers, servers, printers, routers, any device at all on the internet. You refer to it as a node. It represents a point of connection or intersection on the network. The network shell is a software program that gives you a command line interface that you can use to manage the network. So it provides a user interface for accessing and managing network resources such as remote computers, files, or services. It allows users to execute commands, transfer files, and perform other network related tasks from a command line interface. Okay. We also have protocol, which is a set of rules and standards that govern communication between devices on a network. It ensures that devices can understand each other and exchange data effectively. Common protocols include the TCP/IP, HTTP, and file transfer protocols. We also have the simple mail transfer protocol, which is the SMTP. So we have the protocol engine, which is a software or hardware component that implements a specific network protocol. It handles the low level details of data transmission and reception according to the protocol rules, depending on whichever protocols you are using. So we have the bridge that connects two or more network segments together. So you have two network segments. You have the bridge that can stand as the intermediary between the two of them. You connect them together using the bridge. So allowing data to flow between them. So we have the gateway that provides access to it operates on the data link layer 2 of the OSI model. You can just go to Wikipedia, try to look for the OSI model. So we have the gateway, which is a network device that provides access to other networks, often within a different protocol or architecture. It acts as a translator or intermediary between networks. It can be used to connect a local network to the internet or to connect different types of networks together. We have the router, which is a network device that forwards data packets between networks based on their destination addresses. So on the in the OSI model, it's on the layer 3. It determines the best path for data to travel and ensures efficient routing of packets. We also have the repeater, which is a network device that amplifies or regenerates network signals to extend the range of a network. It helps to overcome signal attenuation over long distances. We have the modem that you can refer to as the modulator demodulator. So it's a device that modulates and demodulates signals to enable data transmission over analog telephone lines or cable networks. It converts digital signals from the computers to analog signals that can be transmitted over telephone lines and vice versa. So that will be all for other terminologies associated with networks. Let us now talk about topology. So, network topology refers to the physical or logical layout of a computer network, defining how nodes and links are arranged. Different topologies have varying implications for network performance, reliability, and scalability. Here are three different common types of network topologies. We have the linear bus topology. In a linear bus topology, all devices are connected to a central communication medium usually using a cable. Data is transmitted along the bus to all the devices, but only the intended recipient processes the data. So you are transferring data and an address. You are transferring instruction and the address of the recipient device. So when every other device gets access to the data, they will know that okay, this data is not for me. This is the address. So when the data gets to the appropriate device, it will detect the address, match the address, then it will use the data and the instructions whatsoever. So it is simple and cost effective to implement. It is easy to extend by adding a new device. So it is susceptible to performance degradation as the number of devices increases. So an example, Ethernet networks using a single coaxial cable. So in the star topology, all devices are connected to a central hub or a switch. Data is transmitted through the hub and the hub directs the data to the intended recipient. Alright. So characteristics, there is a centralized management and it is easy to troubleshoot. If one device fails, it does not affect the others, and it is dependent on the central hub. If the central hub fails, then the entire network might fail as well. So, for example, the modern Ethernet networks using a central switch. So it is more like you having a star, then you have a central node. So the central node is what is supplying resources to every other node. So you also have the ring topology. In a ring topology, each device is connected to two neighboring devices, more like in a ring. So everything might be connected like in a ring, in a circle, or however way you understand it. So forming a closed loop. Data travels in one direction along the ring until it reaches the intended recipient. Okay, equal access to the network. Each device has the same transmission capabilities in a ring topology. Network expansion can be challenging as each device must be physically connected in the ring. A failure in one device can disrupt the entire network because obviously it is in form of a ring. So when one device fails, you are more like severing the network. So we also have the mesh topology where every device is connected to every other device. Okay, this provides multiple paths for data transmission, enhancing reliability and fault tolerance. High redundancy and fault tolerance is a characteristic of the mesh topology. It is complex to implement and manage due to the large number of connections that have to be in place, excellent performance and reliability. So, an example are the internet backbones and some high performance computing clusters. We have the bus topology, which is a special type of the linear bus topology. So it's a type of linear topology where all devices share a single communication line or cable. Transmission data is transmitted along the bus and each device reads the data recognizing its address. It is simple and easy to implement. It is affordable for small networks. It is susceptible to performance issues and network disruptions if the main cable fails. Example, early Ethernet networks using a single coaxial cable. Okay. So choosing a topology depends on factors such as the size of the network, the cost considerations, reliability requirements, and the ease of maintenance. Each topology has its advantages and disadvantages, and the appropriate choice depends on the specific needs of the network and its users. Okay, so now let's talk about network security. So, talking of network security, this is a crucial aspect of the modern day technology that involves implementing measures to protect the confidentiality, integrity, and the availability of data transmitted over a network. As networks are susceptible to various threats, including unauthorized access, data breaches, and malicious attacks, adopting robust security strategies is very essential, and these are some key aspects of the network security and the possible strategies to consider. So, the first one is authentication and authorization. Authentication is verifying identity, while authorization deals with granting appropriate permissions. We have encryption, which involves encrypting the data during transmission to ensure that even if it is intercepted, it won't be readable. So we have the firewalls, which is used to monitor traffic that is coming in and outgoing from the network. So allowing or blocking data packets based on the predefined security rules. We also have the IDPS, which deploying systems that monitor networks or system activities for malicious behavior or policy violation. So we have the virtual private networks, we have the access controls, we have the security policies and procedures. We also have security audits and monitoring. We have patch management. These are all key aspects of network security. So, possible strategies to enhance network security. I think top on the list will be employee training and awareness. Because after securing your network, you need to ensure that the people operating the network are not in any way jeopardizing the security of the network through their own actions. So we also have the multi-factor authentication, which adds an extra layer of security beyond just the passwords. So you might be having something like after you've entered your username and your password, you have to enter a token, or you have to verify your email or your phone number and all those things. So regular security audits and assessment, response plan. We also have network segmentation as well. So regular software updates, encryption for data in transit and the data at rest as well. So we have collaboration with security vendors. This will work as well since it is their area of specialization. Regular backup and recovery procedures. Then we also have continuous monitoring and threat intelligence. All right. Network security is an ongoing process that requires a combination of technology, policies, and user awareness. By adopting a comprehensive approach and staying vigilant, organizations can significantly enhance the security posture of their networks. Okay, so that will be all for computer processing models and networking. We spoke about the processing models. We spoke about networks, the different type of networks, some terminologies associated with networks. I spoke about the brief history of the internet. Then I spoke about topology and the types. Then network security. So that will be all for this tutorial. Don't forget to like the video and subscribe to the YouTube channel. Got any questions? The comment section is open. Thank you very much for staying till this point. See you in the next tutorial, and bye for now.